Presentation is going to be about the Martel Pond water quality investigation that Roque, Lacia, and Luke did. Firstly, there's just a short montage of some pictures of Martel Pond and what it visually looked like when we all went to do the investigation. Okay, so to start off, I'm going to talk about eutrophication. Now, eutrophication is the process of excessive richness of nutrients in a lake or other body of water, frequently due to runoff in land, causing dense growth of plant life and eventually the death of animal life from lack of oxygen. And this can be, eutrophication can be caused due to pollution. There are two main types of pollution: point source pollution, which is when there's a one identifiable source where the pollutants are being discharged, and then there's non-point pollution, which is pollution resulting from many sources instead of just a single one. Major sources of pollutants today are domestic waste, insecticides and herbicides, and food processing. And these tend to have large amounts of nitrates and phosphates, which are the pollutants that cause things like algal bloom and therefore eutrophication. One can monitor these pollutants by calculating the water quality index as we did in this investigation. Additionally, one can look at pollution and biological oxygen demand. Typically, in a body of water, when there's a high biological oxygen demand in comparison to whatever the standard or equilibrium level of that body of water is, it's probably going to mean that there is a point source pollution injecting a bunch of pollutants in the water, which is then causing all the plant life in that area to require a lot more oxygen and therefore demand it in order to break down all those new nutrients. Another way which we can look at pollution is through biotic index. So biotic index is basically just an index which can tell whoever is looking at it or the diversity of the organisms in the water. So if there's a high biotic index, it's typically going to mean that there are a lot of diverse animals living and being sustained in that area. To see if there is pollution present, one can look at animals like frogs, which are amphibians and they breathe through their skin. And the frogs and other amphibians like these require the water quality to be good and for there to be really, really low amounts of pollution, because since they breathe through their skin and they're constantly in water, they're constantly in touch with these pollutants if they were to be in there. So this is how one can see biotic index and pollution. The way that we can see biotic and abiotic components and human activity and how they correlate to each other is firstly through conductivity and abiotic components. Conductivity in the water is a way to see the amount of dissolved solids in the water, which can highly affect the water quality. And if there are high levels of conductivity, this can mean that there are high levels of dissolved solids, which can be due to human activity depositing waste into rivers or simple urbanization around the bodies of water, which causes negative eutrophication effects in the water. And then another way which we can look at it is through biotic components. And like I said earlier, this can be seen in the biotic index. If there's a high biotic index, then a lot of different organisms can't survive in this area, which is typically going to mean that the water quality is good and that the human activity, if it is occurring around that area, is not affecting the area or the environment of these organisms negatively. So these are the main steps of eutrophication. Firstly, there are going to be too many nutrients in the water, normally due to pollution. And then there's going to be algae overgrowth due to the algae using these nutrients. And then then the algae is going to eventually die. The bacteria is going to decompose the dead algae, use most of the oxygen in the area. And then the animals in the area will eventually die to the lack of oxygen and the entire ecosystem will die down. And how does eutrophication relate to Martel Pond, and what is Martel Pond like today? So Martel Pond is a community pond, and if we don't take care of it, the pond will give into the effects of eutrophication. Martel Pond today is based off of and compared to other bodies of water, and is somewhat clean, but it looks like eutrophication is either happening now or is about to happen unless some action is taken. So this is why we did our investigation. And our investigation consisted of us testing for dissolved oxygen, which I've talked about, pH, which shows the acidity and basic level of the water, nitrates and phosphates, which are just measures of how much nitrogen and phosphate there are. Conductivity, which, as I said, is another way to measure dissolved solids in the water. Biotic index, and turbidity, which is a way to measure the non-dissolved solids, or the non-dissolved solids in the water. And then finally, water temperature.
For the data we collected, we had a dissolved oxygen of 10 ppm, a pH of 7, our nitrite level was less than 5, our phosphate level was 1, turbidity was 22.5, our water temperature was 27.8 degrees Celsius, and our conductivity was 707. Overall, we had a water quality index of 52.94. This falls within the average water quality rating. Most of our scores varied in the middle range of the scales, and the tests that did lie on the low end of the spectrum were phosphate readings, dissolved solids, and suspended solids. On the left in red is actually data from Martel Pond in 2018, and what we see from our data is that the water quality is actually getting worse at Martel Ponds. We've outlined 3 possible solutions for improving the water quality at Martel Pond. The 3 are reducing phosphates, reducing dissolved solids, and reducing the suspended solids. Each one of those has its benefits and negatives outlined. Another possible solution would be to create an embankment around the pond to basically prevent runoff into the pond. This would catch extra nutrient runoff, thus stopping large algal blooms, and it could also prevent different things from erosion. However, this could end up being destructive to the actual environment around Martel Pond. The few things that we could actually do as individuals would be to cut back on the amount of fertilizer we treat our lawns with. We could use environmentally friendly pesticides. And also, if you have a lawn mowing company, you could actually ask them to stop blowing the leftover grass or leaves if you're near a communal body of water such as Martel Pond. Attached here is our bibliography.